reflection and absorption. We talked about the fact that light is made up of waves of electromagnetic energy. But what's unique about these waves as opposed to microwaves or radio waves or any of the other electromagnetic waves? These are electromagnetic waves that we can see. And we talked about the frequency of waves, the wavelength of waves. Remember the longer the wavelength, the bigger the wave, the shorter the wavelength, the smaller the wave, right? And it's actually the wavelength of light that's going into our eyes that lets us see the different colors that we see, and that's what we are going to be looking at today. And I've got these 3 beakers up here. What is in these 3 beakers, Sophia? Colored water, right? Water and food coloring, nothing special in them, just some water and some food coloring. But here's what's interesting, and we talked a little bit about this last week. Does anybody know what's special about these 3 colors of water? Interesting, all 3 of them can make different colors, and in fact these 3 colors and I've got it on the board behind me. I don't know if you can see it but these 3 colors are what we call primary colors. And primary colors are the 3 colors that basically can make any other color. But no 2 colors can combine to make them. Has anybody ever mixed colors together? Before, maybe color paint colored, watercolored, even colored pencils, you can kind of color different colors and make new colors, right? Caleb, what's one combination that you might have? Are there any colors we could mix together to make red? Can you mix 2 colors and get red from it? We can't. Can we? What about yellow? Can you mix 2 colors to make yellow? So the unique thing about these primary colors, these colors cannot be created from mixing other colors. Now what does that have to do with light? That's the real question that we are looking at today. And we said that anytime we see color because it's reflecting light. And specifically, it's reflecting certain wavelengths of light that allow us to see that object in certain colors. So when we see this red water in the beaker here, we see this red water because the beaker, the pigments in the liquid and the beaker are reflecting red light. And that lets us see all of the different colors. We'll start with red, all right. See if I can do this without making too big of a mess. Guarantee I'll spill something before it's over. But we'll see how it goes. I tried to wear a white lab coat so hopefully you can see better. What do we have? We've created a new color from 2 of our existing colors. So if we see something that's orange, if I've got an orange shirt on today, what color light is my orange shirt reflecting? What color light's it reflecting? Red and yellow, right? As we see colors, when you see yellow light and blue light, what color is it going to look like to you? What color do we say that's going to make? Somebody said it earlier. What color do we have? I know it's probably hard to see over the computer. Purple. We've got purple, or we might call it a violet color, right? We started out with our red, our yellow, our blue, and our green. And now let me scoot these down just a little bit so we can kind of line them up here. Now all of a sudden, by combining a few colors. But these 3 colors here, we call them secondary colors. But our primary colors are the colors that we cannot combine any other colors to make the secondary colors the colors that we get when we combine 2 of the primary colors. Yes, we can. I see some of you nodding your head. We certainly can. So let's take a look at that. Let's get about that much. Make sure I don't run out. And I'm just going to go down the line and combine these and then we'll talk about them a little bit. Because the interesting thing is, we can create essentially an unlimited amount of colors. Now the problem is there's a limit to what our eyes can see. Have you ever seen 2 colors that might have been a little bit different? But it was hard to tell they were different because they were so close together. Have you seen that before? And that's what happens once colors get, I'd say once colors get close enough together, they're really hard to distinguish between other colors. Tertiary colors that is made by combining secondary colors with primary colors. And the idea is, when you open a box of crayons, anybody ever get one of those really big boxes of crayons? TS got, what is it, like 64 crayons? You've got lots and lots of colors in there, but then you start looking at the colors and it gets to the point where TS kind of hard to tell the colors apart. And these colors that are just kind of these made up words and all of that. And sky blue and blueberry blue and blue and blue violet and violet blue and all these different colors and shades of colors. And that's kind of what we are doing here and that's essentially what they're creating. They're creating this idea of by mixing your 3 primary colors you're able to create any of these other colors. Now here's the thing if I held this up and said what color is it what would you tell me? And I don't know how well you can see it over Zoom. So it's going to be a little bit darker a little bit more of a reddish orange than the actual orange here. So that's the idea that by dot the amount of different wavelengths dot of light that's being reflected off of an object dot we are able to see all of these different colors dot plus many more just from dot what's being reflected back dot into our eyes. So again the lights dot in the ceiling dot what color is the light dot coming from these lights up dot in the ceiling. That's not yellow dot what color is it? I know you can't see the ceiling lights dot because the camera is not dot aimed there, but what color are my ceiling lights, Alan? Now what about my poster board here? What color is my poster board? White, and you asked what happens. If we mix all the colors, well it depends on what you mean. Why mix all the colors? Because when the light hits an object. If all of the colors of light are reflected back, what color was the light? We started with white light. So if we have white light and we see white when we look at an object, what colors are being reflected? When I say what colors are reflected, all of them, if all the different colors that hit an object, all the different colors of light that hit an object are reflected back to us. So when we combine the red light, the yellow light, the blue light, all the different colors of light together, we see white light. Where they had that paint that didn't reflect any light, what color do we see when no light's reflected? Blank black, so black. We say is the absence of color when we see something black, especially we looked at that Vanderblack paint, right, that didn't reflect hardly any light. So when no light's reflected, the absence of any color, we are going to see black. When all colors are reflected, the presence of all colors at once is going to give us what color it's going to give us, say it if you know what color. And everything in between, every other shade of color that we see comes from different amounts of these different colors being reflected. So that's the reason that we see the colors that we see, it's because of the reflection of light off of objects.